A particle where W is attached to C. Let's say this is the particle W. To two tight inextensible string AC and BC. The other end of the strings are attached to two fixed points A and B on a horizontal ceiling. The particle hangs in equilibrium with the strings in a vertical plane with AC and BC inclined to the horizontal 30° and 45° respectively. Find in terms of W the tension AC. So this is tension in A and this one is tension in B. You can solve it by two methods. You can use triangle of force rule. This angle is (75). Now the first method is TA cos 30 is equal to TB cos 45. TA cos 30 is equal to TB cos 45. That is for the cos. Now the W is a TA sin 30 plus TB sin 45. And the weight W, the equation can be given by TA sin 30 plus TB. That's how we write in sine and cos. Now if I have to get the relation between W and TA, that is tension in AC and tension in BC, replace, first we find TA. So TA is equal to, we can see from here, TA is equal to TB cos 45 over cos 30 multiply sin 30 plus TB sin 45. So W is equal to, now you can calculate the values of cos 45. These are all angles, you can write straight away values. TB cos 45 we know is 1 over root 2. Cos 30 is root 3 over 2. And sin 30 is also 1 over root 2. Sin 30 is 1 over 2, not 1 over root 2. Sin 45 is, sin 30 is 1 over 2 plus sin 45 is 1 over root 2. So W is equal to, this cancel, 1 over root 2 root 3 plus 1 over root 2 TB. So if we take root 2 root 3 LCM, so it will be, we have 1 here plus we have to multiply it by root 3. So plus root 3. So W is equal to TB so that is 1 plus root 3 over root 6 TB. So TB is equal to root 6 over 1 plus root 3 W. So that is 0.90 W. Now to get TA, you use the same method, but instead of here we have changed TA into TB, you change TB into TA. So TB is equal to TA cos 30. So here you will write TA cos 30 over cos 45. Cos 45, sin 45 will be cancelled. Let me do this. So part B is W is equal to TA sin 30 plus TB. TB is TA cos 30 over cos 45 and sin 45. We know that cos 45 and sin 45 have same values, so we can cancel it. So that is TA. Sin 30 is 1 over 2 plus cos 30 is root 3 over 2. So that is equal to TA 1 plus root 3 over 2. So this is W is equal to. So TA is equal to 2 over 1 plus root 3 W. So that is equal to 0.73 W. So the value of TA is this, and the value of TB is, so these are the values of TA and TB. There's another method you can solve it, is that we can use the sine rule. This is 60, this is 45, and this is W. So remember this. So if I make a triangle, then this is W, then this is 45, that is TB in this direction, TA this angle was 75, and now this angle is 60. 90 minus this, TA, TB and W. So if we use the sine rule, so let's use sine rule. So sine 45 over TA is equal to sine 75 over W. So TA is equal to W sine 45 over sine 75. Let me use my calculator to. So that is 0.732. So that is the value of TA. Now if you have to calculate TB, that is sine 60 over TB is equal to sine 75 over W. So TB will be equal to W sine 60 over sine 75. So that is equal to W 0.8965. So that is the value of TA and TB. Question number 2 is a particle P of weight 40 N. That is the weight of 40 Newton. So weight is 40 N. Lies at rest in equilibrium on a fixed rough horizontal surface. The force of magnitude 20 N is applied to P at theta degree. The coefficient of friction between P and the surface is mu. We know that F is less than equal to mu r. Given that particle remain at rest, show that. Now the first thing is this is theta and this is 20 N. So if we solve it horizontally, this is cos. So we know the F is this side and R is here. So F will be 20 cos theta. And R will be, it's already 40 plus 20 sine theta. If we use these values, so 20 cos theta is less than equal to mu 40 plus 20 sine theta. So divide by 40 plus 20 sine theta. So this is cancel. So mu is greater than equal to, we can cancel 20 times 1 and times 2. So it will be cos theta over 2 plus sine theta, and that is what we are supposed to prove. Two particles A and B. Let's say this is A and this is B. Have the mass 2m and km. So this is 2m and this one is km. These particles are moving in opposite direction along the some straight smooth horizontal line, so that the particle collide directly. It means the movement of this is in this direction, they are moving in opposite direction towards each other. Immediately before the collision, A has a speed of 2u before they collide. So this is moving with the speed of 2u, and B has a speed of u. B is moving in this direction with a speed of u. The direction of motion of each particle is reversed by the collision. The direction of motion of each particle is reversed by the collision. It means just after collision, when we reach here, they collide. This start moving in this direction and this one start moving in this direction. This question is not saying that it stopped. It's moving. Immediately after the collision, the speed of A is u over 2. So now this speed is u over 2. The speed of B is not given, so let's assume it is v. Find in terms of m and u the magnitude of impulse exerted by B on A. So impulse on A, Now the weight of A is 2m. Its speed after the collision was u over 2 minus 2u. This one is in opposite direction, so this is minus 2u, so it will become plus 2u. So that is equal to 2m. u over 2 plus 2 times 2 is 4. 5u over 2. 2 and 2 cancel, so 5mu. Find in terms of m and u the magnitude of impulse exerted by B on A. So that is 5mu. Part B, show that k is less than 5. This k. So 2m multiplied to u minus km multiply u will equal to the final speed of this, that was u over 2. So 2m multiply u over 2 plus we have put minus here because this is opposite, so u is in opposite direction, so this is minus and plus kmv. 2u this direction, two m to u this direction, km and minus u opposite direction, 2m u2, yes, so this is minus u over 2 and v. So now we have 4mu minus kmu, this 2 cancel, minus mu plus kmv. mu. We have to find the value of k and k. So kmv mu and mu. Let's say this is 5mu minus kmu is equal to kmv. Now this value 5mu and kmu, if k is equal to 1, this is negative value, this is a positive value. If k is equal to 2, 3, 4, it's positive value. If k is equal to 5, this is 0. M is not 0, it means V is going to be 0. So V is, it says in this question, if you recall it, it says in this question that the direction of motion of the each particle is reversed. It means V is not 0. V is greater than 0. So v is greater than 0 only if this value of k is less than 5. Then only it will be. So it shows that k is less than 5. This M1 paper was asked by me from Fahm. So that's why I've solved in a very quick way the solutions. I will continue giving solution of this paper. Thank you for watching and don't forget to subscribe my channel. Maths Rag.